Hello students, today we will study how will you factorize a given polynomial using factor theorem, the first method, and how will you factorize a given polynomial using long division method. So first of all, let's begin factorization of polynomial using factor theorem. So let us start. Factorization of polynomial. So this is our topic, factorization of polynomial, and the first method is using factor theorem. So what does a factor means? First of all, let's understand what does a factor means and how we will utilize this factor theorem. For example, if I say that you have a polynomial fx, such that which is x cube plus 3x square plus 7x plus 8. This is the hypothetical polynomial fx equals to x cube plus 3x square plus 7x plus 8. You have another polynomial gx, which is x minus 3, So what does factor means? How will you say that this gx is a factor of fx? How will you say that this gx is a factor of fx? So if gx is a factor, so how will you say that this gx is a factor of fx? So if x minus 3 is a factor, then x equals to 3 should be a root of fx, that is f3 should be 0. So this is a hypothetical situation which may not end to 0, but we have taken this as an example. Like if this is a situation, then this condition may arise. Now let us take a question. Let us take a simple question where we have been given a show that let us write it here. Let us write it a bit down. Maybe it might be visible. So the question is, show that x minus 2 is a factor of, x minus 2 is a factor of 2x cube minus 3x square minus 17x, factor of 2x cube minus 17x square, 2x cube minus 3x square minus 17x, 2x cube minus 3x square minus 17x plus 30. This is how it should be done. And the next question is, and hence factorize. This is the complete question. Show that x minus 2 is a factor of 2x cube minus 3x square minus 17x plus 30. So this is the factor given. So let us start. We know if x minus 2 is a factor of fx, every one of you know that if x minus 2 is a factor of this polynomial, if this x minus 2 is a factor of this polynomial, then this f2 should be equal to 0. Let us check it. Then this f2 should be equal to 0. Let us take it. f2 equals to 2 into 2 cube minus 3 into square minus 17 into 2 plus 30. This is 8, 8 to 16 minus 12 minus 14 plus 30. How much it is? This is 34. So this is altogether 46 minus 46. This is equal to 0. So F2 is coming 0. Therefore, x minus 2 is a factor of fx. This is clear. X minus 2 is a factor of fx. What we have studied is, if this x minus 2 is a factor of this polynomial, if x minus 2 is a factor of this polynomial, then x equals to 2 should be a root. If x equals to 2 is a root, then if you put 2 in this polynomial, it should come 0. So we have put 2 in this polynomial, the value is 0. It means that x minus 2 is a factor of this polynomial. So this is being clarified that x minus 2 is a factor of this polynomial. Now how will you factorize it? Using factor theorem, how will you factorize it? This is the very basic thing, that how will you factorize it using factor theorem. So keep it in mind with a very important thing. Keep it in mind a very important thing. That some of the things you have to write in rough. When you use factor theorem, some of the things you have to write in rough. I will tell you the trick behind it. How will you write this thing in rough? How will you write this thing in rough? So let us begin. This part which I am doing, you have to do it in rough. You have to divide. This part should be done in rough. Since the question is factorize using factor theorem, we are using factor theorem, yeah? So it should be 2x cube minus 3x square minus 17x plus 30. So it is 2x square, 4x square, so this fx is coming x minus 2. This part is the fx, this part is the fx. This fx equals to x minus 2 into 2x square plus x minus 15. So when you write it like this, fx, it is 2x square plus 6x minus 5x minus 15. So it is x minus 2, 2x, x plus 3 minus 5, x plus 3. So it is x minus 2, 2x minus 5, x plus 3. So this is how it has got splitted. This is how it has got splitted. You see, one of the factor is x minus 2. The other factor is 2x minus 5 and the other factor is x plus 3. So we have factorized this. But you don't need to write this complete thing in the fair part. You do not need to write this complete thing in the fair part, just because the reason is it has been asked to use factor theorem. What it is being asked? It is being asked to use factor theorem. Since it is being asked to use factor theorem, you don't need to write this complete thing in the fair part. From here you get a hint. From here you get a hint that this is also a factor and this is also a factor. So you get that x equals to 5 by 2 is a root and x equals to minus 3 is also a root. So from there you write, using integral root theorem, you can write here rational theorem as well, because since it is the leading coefficient is 2. Using rational root theorem, the roots of fx are plus minus 1, plus minus 2, plus minus 3, plus minus 5, plus minus 6, plus minus 15, plus minus 30, plus minus 1 by 2, plus minus 3 by 2, plus minus 5 by 2. Like this, you can write. After this, you have to do hit and try, but you don't need to do hit and try. You know the answer. On what value you have to check? Directly write f 5 by 2. This is equal to 2 into 5 by 2 whole cube minus 3 into 5 by 2 whole square minus 17 into 5 by 2 plus 30. This will somewhere end to 0. Again you will write somewhere. Again you need to write f minus 3. You will write 2 into minus 3 to the power 3. 3 into minus 3 to the power 2. Minus 17 into minus 3 plus 30. This will also into 0. So from here it means, what does it mean? From here it means that 2x minus 5 is a factor. From here it means x plus 3 is a factor. Therefore fx equals to x minus 2, 2x minus 5, x plus 3. This is how the factor theorem is utilized. Just what you need to know is, if the fx is a cubic polynomial and the factor is a linear polynomial, just divide this cubic polynomial by the linear polynomial. The quotient will come a quadratic polynomial. Split it. You will get 2 other factors, and from 2 other factors you will get 2 other roots. We put it like this. If the quotient is a quadratic polynomial and the dividend is a biquadratic polynomial, just divide it. You will again get the quotient a cubic quadratic polynomial, and again carry from these two you will get again these 2 roots. But a next situation may arise. I'll tell you it later on.